Hopefully you're here for Elasticsearch. If you're not, you're now here for Elasticsearch, so welcome. We'll go ahead and get started. So my name is Brian Ritchie. I'm the CTO at Zeo Health, and been in software development for a long time. Done a lot of different things, all the way from, I started out as a DBA, went into doing software development, done some management. Now I'm back in this role where I'm doing a little bit of everything. So I wanted to talk to you guys a little bit about Elasticsearch today. And so we're going to start out by some introduction to Elasticsearch. We're going to move into, okay, how do I get my data into Elasticsearch? And then we'll talk about a little bit of security. Then we'll put it all together, kind of show you a demo of what we did. So a lot of this is based on some work that we did recently at our company. Let me shut the door here. That better? Yes. All right. Sorry, you got to repeat everything that I just said? No. All right. So I came into a company where, like many, SQL Server was kind of the center of the universe from a data perspective. And so all of our data was in SQL Server. All of our applications were updating SQL Server, and everything was trying to read from SQL Server. Okay? And so I was coming into a situation where I was like, okay, how do I modernize this architecture? And so that's kind of what I want to talk to you about is, how do I take an application that was really great, and how do I modernize it? That's kind of how we're going to go through this talk. So we're going to kind of talk about your application. So you built this application, right? It was really nice. Had that new application smell to it. You were happy with it. You loved this thing, okay? Now, then something happened. You had a bunch of users. Our applications wouldn't have been great if it wasn't for all those users, right? So all those users come in, and they're using our thing, and they're like, oh man, if these people would just stop coming in at 2 in the morning, or what are they doing all coming in on Monday? I mean, really. So they're all kind of cramming in there using your thing, right? And you're trying to run, and you're trying to optimize it, right? And then you got requirements changes. Like, these people want new features. I don't understand this, but they do, right? And so how do you adapt to that? Well, sometimes if you don't adapt fast enough, right, your application leaves you on the side of the road, and you're like, I used to love this application, but now I'm not real happy with it, right? So you're kind of sad. Your application's steaming. And this is what your users are doing, right? Your users are looking at their watch, and they're like, oh, this application is running slow, or it's not up, or there's something going on with it. It's not giving me what I want, okay? And typically, you've got contention, right? Contention for a limited resource. Typically, if you don't have contention, you didn't design your application correctly, right? Because you've got contention somewhere else. Maybe it's a web server process that you didn't write correctly, and so it's slowing everything down. But typically, if you have a SQL Server application where it's the center of the universe, it eventually becomes the point of contention, right? You can scale out your web servers, you can scale out all these things, but your SQL Server now is the bottleneck, okay? So what do? Well, one option is you do this, right? You take your application that you loved and you throw it in the dumpster, and you say, you know what, I got to start over. Sometimes that's a great option, but sometimes you have to take what you have and evolve it, okay? And so this takes you back to, you want to pimp your ride. You want to take your old beater, right? You want to make it hot again. So that's what we're going to talk about. So first of all, we're going to talk about Elasticsearch. Now, who knows something about Elasticsearch in here? All right, quite a few people. Awesome. Elasticsearch started out as a search engine, okay? And it was built on top of some open source code, right, that is now exposed as a RESTful API, okay? And from there, they started adding a bunch of other capabilities to it, okay? And we'll kind of talk about that. But have you heard of the Elk Stack? Okay? So a lot of people, when they use Elasticsearch, they think of the Elk Stack, okay? And the Elk Stack stands for, you got the Elasticsearch, You got the Logstash, and you've got Kibana. Okay, so logs, and they're kind of in the opposite order. Logstash is how you get the data in. Elasticsearch is how you index it, and Kibana is how you look at it. Okay, and so typically a lot of people that use the Elk Stack are using it for logs. So you'll take your application logs, you'll run it through Logstash, and you'll put it in there, right? So your operations team or you as a developer, right, now have some tools to go diagnose problems. And that's a lot better than if I've got 20 machines and I've got to say, okay, which one did this problem happen on, right? It's all in one place. So if you're not doing something like this, it's a great option. Splunk is like another tool. I love Splunk as well, but it's more expensive. So the Elk Stack is a lot more cost effective. So we're going to talk about using this in a little bit different way, okay? So instead of using this for just my logs, I'm going to use this for other parts of my application. So it's actually going to be not just a support tool, it's going to be integrated into my application stack. And so a few reasons why I might want to do that is it's extremely fast, okay? And you'll see it's an extremely fast response time for searches, okay? And a lot of times when you have a relational database, everything looks like a nail, right? It's the hammer that you hit everything with. Okay, so if I've got a relational database, hey, I'll just add a couple more tables. It's easy, right? All the infrastructure is already there. But what you'll end up finding is it's not an optimal use of that relational database for all scenarios. And so this is really good at search. It's document-centric. We'll talk a little bit about that, the difference between like a document database and a relational database. And it allows you to index everything. So a lot of times with SQL Server, you'll say, okay, I'm only going to index these fields because of a specific reason. Anybody know what that reason is? It's because it might speed up my reads, but it's going to slow down my writes. Okay, so the more indexes you have, every time you write to SQL Server, it has to rebuild that index, right? It has to update that index. And depending upon how many writes there are, right, then you've got page splits and you've got all this other stuff going on that slows it down. Okay, so then you say, okay, well, I'm only going to index what I have to index. This gets back to our users. Our users want to search on everything, right? And so you've got this contention of the DBAs or the developers saying, no, I can't index everything. The users saying, I want to index everything. And so now you've got a different kind of contention going on, right? So this allows you to index everything, which is great. It does sharding and partitioning of your data. So a lot of times that's how you optimize stuff in SQL Server, except now you have to get the Enterprise Edition and you've got to redo your table structures and a bunch of other stuff. This is all just baked into the product. Okay, and it's also distributed. So you're not going to be limited to one big box. You're going to split this out over multiple machines. Now, I was kind of out there looking, you know, our use case is not this huge, but you can see there's some very large use cases out there. So what you can know from this is you can use a very small scenario, which I'm going to show you on my laptop, okay, where I'm running Elasticsearch right now, and I've got over 100 million records there. Or you can go up to 3.5 billion search requests a day and 2,000 plus nodes. So you can scale from very small to very large, okay, without re-architecting, which is great. So now your users look like this. They're nice and happy, okay? That's how we want users to be. And so that all sounds awesome. So how do I hook this into my system? Okay, who's familiar with Cqrs? Quite a few people. All right, awesome. So this is not exactly Cqrs, but when I was putting this together, I was like, you know, this is very similar to the ideas behind Cqrs, okay? So Cqrs is, you've got these commands that you've separated out all your updates into, and a lot of times you can queue those and do other things like that. And then you've got this persistent view model, and the persistent view model is what your users see. And so a lot of times you have something on the back end that you need to optimize for more OLTP type scenarios, right? But your users now can get an update that's fast for them and gives them the data they need, okay? And so you can see kind of from this picture here, I've got all my transactional data going on, I've got my systems. This is kind of the scenario we were talking about before. I've got all the stuff that I've built. I can't go and change everything all at once. I can let that stuff run over here. I can build this persistent view model, which is the data that needs to be together for search and for display, okay? And so you can kind of now start thinking about it from a UI guy's perspective, right, Evan? So as a UI guy, you're like, okay, this is how my screens look. This is the user experience I want to have. How does the data need to be stored to make that optimal? And I'm not now depending on how this back-end data was stored to make those processes optimal. Make sense? So a couple different options on how you do that, okay? So if you've got a data pipeline that allows you to insert things into it, that would be the easiest thing to do. So like in our system, we had a lot of queues, okay? We were using ActiveMQ, but you might be using Rabbit, you might be using Kafka, you might be using different things, right? That allows you to insert something into the processing of that system, okay? Like in ActiveMQ, you can take a message and have it, when it hits a topic, you can spread it out and have multiple things now be able to consume that message. So you can have the thing that was consuming it before, you can now have a copy of that message go off and be consumed by something that's doing search, okay? So if you've got queues in place, that's a really great place to start inserting some of those processes, okay? If you don't have queues in place, we also, for us, we had some places where it was really easy to hook it into queues, other places we had to go into some individual components and start adding that data in. So in our particular case, we're dealing with healthcare claims data. So we had healthcare claims data that was coming in for adjudication. We have an adjudication system, that's our business. And so we wanted to index data that was on the way in, and then we wanted to index the data on the way out. So we had now had this full picture of the data. So not only what the provider sent in to get adjudicated, the results of the adjudication, and then what was sent back to them, okay? And now, before, that was spread across multiple databases, right? Because we had validation systems, we had the adjudication system itself, we had results going back. So now I've got stuff spread across Postgres and SQL and different places, okay? And I didn't really have a good place to bring that all together. So now Elasticsearch allows you now to say, okay, what is all the data that I want to bring together to get this consistent view across everything, okay? So if you can hook it into queues in that process, that's great. Another way to do it is to replicate data after it hits your database, okay? We had to do some of that too, because we didn't really have a good way to hook into the processing. So we said, okay, every X minutes, I'm gonna go to the database and I'm gonna see if any new records are there, or see if a change is there. So if you have an update field that says this was last updated at this time, maybe it's an auto-incrementing table, right, where you can say, okay, I've got this identity column, and every time it goes up, I just look for the next one, okay? And that allows me now to replicate that stuff into Elasticsearch. Now, Elasticsearch, and we'll talk about this a little more when we talk about documents versus tables, you're gonna have to re-index that entire document, okay? And we'll talk about what it means by an entire document, but you have to index the whole thing, okay? So in SQL Server, a lot of times you can go in and say, okay, well, I want to update this one field, and so I'm making lots of little small changes. Elasticsearch, so that the search is fast, you have to update everything at once, okay? So you have to think about that when you're putting your data in, because you're going to take that hit if you need to update it, okay? And the final option, which is probably the least awesome, but depending on your use case, it might be what you need, okay? You could have a batch process to do this as well. So if you said, okay, for this particular data, it could be a day old and it's fine, okay? You might have something that runs at a particular time to load that data in. That's kind of a data warehouse style ETL process. Now, Elasticsearch has a different way of looking at data than SQL Server, but there's some analogies. So you can kind of see up here, we have databases which are analogous to indexes, okay? Which is kind of confusing because in SQL Server, tables have indexes, right? But in Elasticsearch, an index is basically a database. It's a collection of data that can be of different types, okay? Tables are analogous to types. So you have a type of document that has a particular schema. Now, Elasticsearch is schema-free, so it's not going to force you to have a specific schema. But if you're going to find stuff, you're probably going to want to have a consistent schema, right? You're going to name things the same way so that you can find things. And so the schema is going to be enforced by you, not by Elasticsearch. And then you have documents. So a document is going to be a collection of data. Okay? Now, when you define your indexes, you've got some options. Okay? So a couple different reasons you might define an index. Now, we talked about that it's kind of like a database, so you could say, okay, well, all these entities are kind of related, so I'm going to put them in the same database or the same index. But then I may want to have multiple indexes for different reasons. So if you're used to kind of the Elk Stack type of model, a lot of times you'll have different indexes based on time. So you can, each day, maybe you'll start a new index, and you'll put all the logs for that day into that index. And then it'll automatically create a new index for the next day. And so if I want to search, I can tell Elasticsearch, hey, I want to search across all of those indexes using the same query, and then bring that data back. And then if I want to delete data, now I can just drop off that whole day's worth of data. So I'm not individually going in and trying to delete data out of this larger set, okay? And if you think about the way that users search, a lot of times they'll search for data based on time as well. And so if you know the time, now you can send them to the appropriate index. Another reason to do it would be for a multi-tenant or for a security type of reason, okay? And that was one of the models that we used. So we said, okay, we have these different customers. We have a multi-tenant system, and it's software as a service. And so when they're doing their search within their index, okay? And so you don't need to say every time you do a search, I need to put this extra something on my where clause effectively to limit them to seeing just their part of that table, right? Now I can say, okay, you can only see this one index. All your searches, regardless of what you put in, are only going to hit against the documents in that index. So it's really great for multi-tenant. When you start reading more about this, sometimes you can even have per user, you know? You could have every single user could have a different index if you wanted to. It just depends on your use case. So when you're modeling your data, you need to think about the data differently than you would with a relational database. So in a relational database, you can see you have these different tables, right? And so we're all used to modeling with tables. We've got our entity relational diagrams. We're breaking stuff down. We're looking for duplication, right? We don't want to have duplicate data. So we're putting keys everywhere, okay? Well, what does that do when you want to retrieve data? It slows it down, right? Because now you have to do joins. And every time you do more joins, that means more work for the database. And so in this model on the right, you can see you're actually putting things together, okay? And so within a document, you might have nested relationships within that same document. And so it really depends on what am I trying to search on together? What am I trying to retrieve together? Okay, and I may index something multiple times in different ways. Like in our particular case, we had a claim, okay, a healthcare claim. And a healthcare claim has claim level data, and then it has service lines, which are basically the procedures that were done on that visit, right? So if I wanted to allow somebody to do a service line search at a more granular level than at my claim level, I might want to index those individual service lines so that I can bring them back quickly. But then I may want to also then index the claim with the service lines in it. So now I could search the claim by service line and the service lines by service line. So if I'm looking for a particular procedure code, for example, in my services, right, I could do that against my service line index or types. And if I want to do it against the claims, I can do it against that one. Okay, and so when I'm retrieving data, I can only bring back those individual service lines versus the entire claim. That make sense? So when you're building it for search, you don't always want to say, I don't want to duplicate data. You may want to duplicate data for the type of search that you're doing, okay? And that's what you then build into that upstream process. So when something updates, you update the different indexes in the particular way that you need to update it. Okay, and you also, as you can see here, we're not just talking about kind of a flat entity. You can have related data down inside it. And Elasticsearch will actually allow you to even search for, give me all the people with a child named Michael, okay? But when you do that search, you're actually gonna retrieve this whole Jonathan record. You're not just gonna retrieve the Michael child. And so if you're looking for the parents, right, based on their child name, that's a great use case. If you're actually just trying to get the list of children, you might be now getting a lot of extra data that you weren't expecting, right? And that might be a reason to index it different ways. Now, most of the time when you put data into Elasticsearch, it just magically figures out what your data is, okay? It just says, oh, that's a number. They're putting numbers in here. I know that's a number. Awesome. Or you're putting text in there. Now, it has some built-in stuff to say, okay, if something's hyphenated or if there's underscores, I'm going to allow that to be separated out, okay? And so sometimes you'll have something like a file name, okay? And if I'm looking for a file name, I don't actually want it to break those up into separate pieces. I want it to stay together as one string, okay? And so sometimes you'll have to go in and tell it, okay, like in this particular case, I had an EDI file name. I don't want you to analyze that and break that up into individual words. I want it to stay together because that's one thing I'm looking for. If you don't do that, you'll start getting weird search results back, okay? So the other thing about this is you have to do this before you put your data in, okay? So as we were going through this process, we were like kind of new to Elasticsearch and we were putting stuff in there and everything was running great. And then we hit something like this and we do a search and we're like, oh, that wasn't what I expected. Now you got to go back and reload all that data, okay? So it's good to upfront kind of look at these particular scenarios and make sure you get your indexes set up properly. You also want to kind of set up where we were talking about building different indexes, maybe based on tenants or time. Get that kind of thought through as well up front. The rest of it can kind of evolve, but those things are a little harder to evolve because you got to reload data. The next thing to think about is security. The security of your data, if you look at Elasticsearch out of the box, there's no security, okay? You just connect to the REST endpoint and you can start updating it, okay? So you need to put a security layer on front of the Elasticsearch, okay? Now they have a couple different ways to do that. Elastic Stack, which is what they renamed the Elk Stack. They call it the Elastic Stack now. They have a security piece built into that. That's a part of their commercial product versus the free open source product. There's also SearchGuard is another one that's out there that you can put on the front of it, or you can build your own custom service to put on the front of it, okay? And a lot of times, if you're gonna use it like internally and you're gonna use like Kibana and some of those built-in tools, you'll wanna use one of these top two options, okay? If you're just using it for your application and you want your application to secure the data, then the bottom option is a good one for you. All right, so I want to take you guys into a little demo here. So this demo uses data from the CFPB. Everybody know about the CFPB? No, okay. So the CFPB is the Consumer Finance Protection Bureau. So the great thing now about the government is they're putting a lot of data out there, okay? And they have loan data for years and years and years that you can get out on the internet now. Now, it doesn't have your names on it, so no fear. It's all been de-identified, but it is a good data set to try out. So basically, I took that data set and I loaded it on my laptop. So I've got 107 million loan records on my laptop running Elasticsearch, okay? Because I was like, you know what, if we're gonna do a demo, we really need something that's over 100 million. Because every time SQL Server gets over 100 million, things start getting a little wonky. Okay, if you're under 100 million, you're probably fine. But once you start getting over that threshold, things start having issues. So wanted to have a good bit of data. To load the data in, and we'll show you some code in the IDE here in a minute, but just to kind of give you a little snapshot, it's really easy to load in. So as we saw before, Elasticsearch takes JSON. Everything's JSON going back and forth. So I use this library to give me a loan record out of a CSV file. So basically gave me a dynamic object back that represented that line out of the CSV file. From there, I took it and I did some mapping to it. So I said, okay, I had to do some data cleanup basically on it before I indexed it. Once I had it in my loan record, second line of code, then I figured out which index I was going to put it in. So I decided, okay, well, let's have different agencies. So there was different agencies in this data. HUD was one agency, FDIC was another agency that was putting data out. So I was like, somebody might want to be, I'm a HUD person, I can log in, I can just see HUD data, or I'm a super user and I can see all the data. Okay? So the index name just gets built off of that. And then you can see that next line where it says .index, that's where you're actually storing it in the index. Okay? And if you want to replace it, you just do a .index again, and it'll replace that document that's out there. So you can see kind of down here, my CSV became this JSON, which then went into Elasticsearch and got indexed. I'll show you some of Kibana here just a little bit. So the nice thing about this tool is it's going to give you a great way to see your data. Okay, so it's going to give you a great way to say, okay, out of the box, without me writing any code, I can go search my data, visualize my data, see trends in my data. Okay, so it's a nice tool to put on top of Elasticsearch that now gives you some insight into your data. And as you're developing, it also is a nice tool to see what's actually inside there. All right. So let's take a look over here. All right. Now, I don't know if you can tell, but I am on a Mac, okay? But I am running Visual Studio on the Mac and running .NET Core on the Mac. So that's another great thing about Elasticsearch is it's cross-platform, okay? So at our shop, we actually run it on Windows, but we also run it on Linux. So you can run it on Windows, Linux, Mac. It supports all the languages that are out there very easily. So the first thing I want to show you just real quick here is this was my search loader that we were looking at earlier. So here's the program. This was just really quick and dirty to get stuff into Elasticsearch, okay? So don't take this one to production, please. So I downloaded this NuGet package for a CSV reader. It takes the header of the file and it builds a dynamic object based on the schema of the header. That's basically what I wanted. I wanted to turn into an object as quick as I could. From there, it goes through this kind of mapping code into this, well, I'm sorry, wrong one, into this loan object, okay? So I kind of went through here and everything in the file, I needed to multiply by 1,000 to convert some of the numbers. I had to look for, things being blank or not and get it into the object, okay? So I just did some real basic stuff to translate it. If the object that you have is the object that you want in Elasticsearch, you don't have to do any of this. This was just, had it in a CSV file and I had to do some cleanup. Okay, so then once I had it cleaned up, I just spun through and indexed it all, okay? And I just had some basic stats as it was running so I could see where it was at in that process. Okay, once that piece had run, I'll take you over here to Kibana. Okay. So I just did a search, and I don't know if you can see up there, but top right-hand or left-hand corner, that was 107 million rows that came back, okay, instantly. And so I can just scroll down here, and it just loaded some more rows, right? It's very quick. Now I did some saved searches here. Let's see here, large loan denials. So it's got like this GUI where you can do searches, or you can do it through this text interface up here. So it kind of depends on how you want to do it, but you can do searches really fast, right? You can also do some visualizations in here. So let's see here. So here's my loans by year. Yeah, it's everything. So it's basically everything that was in that CSV file is in a document. So if I go back here, all right, and I expand this out, here's the JSON that's inside there.
And that is the index?
That is the document that's in the index. Yeah. And so any of these fields are searchable.
Like in SQL, we would call that a table scan if you're searching the entire table. But
yeah.
Elasticsearch magically does this much faster.
Exactly. So every field that I put in is going to get indexed from a SQL Server perspective, right? So normally I'm going to put an index on a field or multiple fields, or I'm going to create a covering index and all those different things. You don't have to worry about any of that because everything is searchable and everything is fast. So it takes some of that planning out, right? You have to plan how I'm going to structure my data, what kind of my documents are going to look like, but I don't have to worry about what things I'm going to search against. So all this data, like we were saying, is searchable. And so then you can, like we were just saying, you could do some really cool visualizations really fast, right? So this is across all of those records. And you can see right here where it says loan_star, okay? The reason for that is I have multiple indexes that begin with loan. So I have loan_HUD, I have loan_FDIC. And so when I set this tool up, I told it, okay, I'm going to be looking for anything called loan_star. And so when it executes a search, it's going to send that across all of those indexes. Okay? So you can kind of think about this as those are partitions that you don't have to care about in this particular case. Okay? Now, when I get to onto the code, I'll show you where you might want to care about it, right? When you're trying to separate data out for a given user. But in this case, I just want to see everything, and so I did this loan_star. So let's see here. I'll just show you another couple of these real quick. Here's Duval County. Thought that was kind of interesting. So they've got all these different visualizations. They got heat maps and all kinds of different stuff. So once you get your data in there, it's kind of interesting to start tinkering around with looking at it. Like one of the things I was kind of interested in when I started looking at this was, there was a big housing crisis, right? And okay, how did loans change during the whole housing crisis? And so you can start seeing those patterns as you put the data into this tool. Okay, so this is something that again comes with Elasticsearch. Now, as you can see, I didn't log into this tool. There was no security on it. Okay, so again, if you're going to use this tool inside your organization, you're going to need one of those security layers on top of it. Okay, if you're just using it from a development perspective, then that's a different story. So then let's go on to the next piece real quick here. All right. So then we kind of talked about how I'm going to get my data into Elasticsearch. Now we're going to talk about how do I get my data back out? How am I going to look at it? And we talked about the security piece, and that's kind of an important piece, obviously, in just about every application. And what we ended up doing was building a custom service that we put on the front of the data, that we could do additional things like security, logging, all that kind of good stuff of the data. Okay. Now, I think I was talking to Sean, and he was talking about how you guys like log all the data that's going in and out, and you look for PHI and things like that.
Entitlements?
Yeah, yeah. And so, entitlements, who can see what kind of data, that's a good place to put that type of stuff. In this case, we're doing it at like a customer level, but you really could start getting more granular than that and saying, okay, at this individual user, maybe they can't see the whole document. Maybe I need to filter out certain pieces of the JSON before I send it back, okay? And so all that kind of stuff is you can put into that service layer. Yes?
So how is the connectivity between the REST API and Elasticsearch? Is it TCP or HTTP? And how is that secure, that particular part between your API and Elasticsearch?
Right, so that's HTTP or HTTPS, okay? And so if you're going to secure that, you probably want to put the service and it on the same box and use a firewall to lock it down. That'd be one way to do it. Another way to do it would be to use one of those other tools to add the security piece as well. And so if you put your service on every one of the Elasticsearch nodes, then nobody's ever really talking to Elasticsearch. And you don't expose Elasticsearch to the network.
You put an API in front of Elasticsearch, and you make the request to the API, and the API ensures that the entitlements are guaranteed.
Right, right. And then you have to lock down that box and make sure that people can't talk directly to Elasticsearch if you're going to use that type of model. Yep. So in this particular application, we've got a small application. This example is in Angular, and we're using JWT. So within my JWT token, it depends on how you want to do this again, how you want to design your JWT. But you can put the indexes that you're going to allow the person to search against inside the JWT. That's how I'm going to do that in this demo. In our application, we actually have some more complicated logic that we have to go through to actually look up what they have permissions to that we do inside the service. So we just get back basically, hey, this is an ID for my user, and then I go interrogate my security system to figure out what they can see, and then I can limit it on the server side. But if you've got a little bit more predetermined logic in terms of what people can see, you might be able to just build into the JWT. And so that's what I'm going to be showing you guys today. So let's just jump back out of this. All right, so over here we've got a .NET Core API. So you can see I've got a search controller, and my search controller, I've got the authorize on there, and inside of my startup, right, I've put some information in here about the JWT authentication piece. In this particular demo, I'm using Auth0, which is a cloud-based authentication service, okay? But you can really use anything that uses JWT. So we use Identity Server where I'm at. So Identity Server can do some of the same types of things, and there's a lot of products that support JWT out there. So that's going to come into my search controller, and we actually built kind of our own JSON protocol for search. And there was a couple reasons for that. One is we wanted to be able to secure the search. And so we didn't really want people putting together Elasticsearch queries all the way out on Angular and building the exact syntax for Elasticsearch. So we wanted them to send us in this fairly simplified JSON, and then the system would figure out what they're trying to actually do, and then we would talk to Elasticsearch. So we translated this JSON into Elasticsearch speak and added the security and the logging and so forth. And once you get into Elasticsearch, you'll see that there's a bunch of different ways to tell Elasticsearch you want to search. So like a wildcard search is different from a regular match search. And so what we ended up doing is saying, okay, if I put an asterisk, for example, in a search field, then under the hood, I'm going to translate that into a wildcard search, and I don't have to worry about that on my client side. And so the service did a lot of that translation type of stuff. And if we ever wanted to move away from Elasticsearch, we didn't want to have our front end being, completely on Elasticsearch protocol. Okay, so it's a nice way to decouple those systems from each other. You can also do aggregates. So we added some basic aggregation support in there. So aggregates are basically, like a group by type of idea, or sums, totals, averages, that type of stuff. So with Elasticsearch, you can actually do a search and an aggregation at the same time. So in SQL Server, a lot of times when we would do searches, you would say, okay, I need to execute this query up front to count the number of results I'm going to get back, right? So you'd execute this query and say, okay, well, how many total could I possibly get back? Because I need to build all my paging and stuff like that, right? So and maybe you want to count the number of dollars or something, other information you want to show. So you have to execute one query to do all the counts. Then you come back and say, okay, now I'm going to actually give you a page worth of data. So then you'd execute another query to SQL for that. With Elasticsearch, you can actually bake that into one query, okay? And you can send it to Elasticsearch and say, okay, this is all my criteria that I'm filtering on, right? This is what I want to aggregate by. And oh, by the way, give me the first 10 records, okay? So you can get everything that you need back to update your screen in one shot versus having to hit it multiple times. Now, once you start paging, you're not going to want to re-execute those aggregates every time. So you'll need a little logic to not do that. But other than that, it's pretty great. Any questions about this so far? Okay, so this is this is Postman. This is a way to test out your API. But once that JSON goes in, we'll jump back over here. Okay, so that comes into my search controller. And so then we have a bunch of stuff that decomposes. So you'll see our model is, there's a fair amount of code in there, but it basically decomposes that initial request that came in and translates it into Elasticsearch speak, okay? So we translate that into Elasticsearch speak, we do our search, and then we put it back into the format that we want to send back to the client, okay? And the one piece of kind of interesting thing inside of here is right here. So I think I was telling you about the JWT that comes in. So when that JWT comes in, okay, that's basically a token that is JSON, okay, and it's usually base 64 encoded, so you have to decode it and stuff like that. But once you get that back, you can now inspect those pieces, okay? And so I'm basically looping through the claims and changing what the person can see based on the security that's coming back from my authentication provider, okay? And so that's a way now that I can filter down, okay, you're just a HUD person, you can only see HUD loans, you're somebody else, you can see all the loans, okay? And that's baked into that search service. Now, a lot of times as well when you're doing searches, you also want to do logging about what people were searching against, right? In healthcare, that's pretty important because you want to know what people saw, what data, and all that kind of stuff. So that's another good thing to put inside your search service. All right, let's go over here. So I have this app I called Mega Mortgage. So we have Mega Mortgage, and Mega Mortgage is the aggregator of all this data for us. So I'm going to log into Mega Mortgage. Okay, now I just bounced over to Auth0 to authenticate, then I bounced back, okay, with the JWT. I've got this little Chrome extension that I like that breaks down JWTs for you. So every time the JWT hits the browser, whether it's in local storage or cookies or anywhere, this thing like sees it and then it decodes it for you, okay? So you can see right here that I've got some permissions on what indexes that I can search, okay? So hopefully you can see that right here, right? And so those are the indexes that I'm going to build and allow the person to see. So if I hit search, so I also use that to populate this dropdown so I can see what they have access to. So I'm going to say, well, let me just do a straight search to start with. okay? So we just went through, again, 107 million records. You can also see it just totaled up the total loan amount. I can't count that high. I don't know if that's trillions or quadrillions, I don't know. But it's a big number. So we just went through and totaled that up all pretty instantaneously, okay? So now I can go through and I can say, okay, well, just show me the ones that are FHA insured between 100,000 and $1 million. Okay. Again, very fast, totaled everything up for me. I can get one page at a time, and oops, all right, I can search through very fast. Now the other thing that's cool is I got the whole JSON back for that loan. So I didn't just get the fields that you see here, I got all the fields. So if I click this view button, I can instantly view the detail, right? So now I don't have to do one search of my high level stuff that I'm gonna put in the grid, and then when they click on it, I'm gonna do all these other little searches, okay? Now in our case, like I was saying with our claims data, it had a bunch of hierarchy inside it. And so, you know, part of this, I had a table here that was showing multiple rows of detail data inside of the detail, right? So I drill down to a claim, and I could see all the procedure codes, all the adjudication rules, all that stuff. It all came back instantly, okay? And so that's another great thing about when you design this is you don't have to do one query for search, one for the screen, and a bunch of different stuff, okay? Once you get that data back, you get all the JSON, you can just display it, okay? And so, you know, very quick. Now I'm using, this is Angular. I'm using PrimeNG. I don't know if you get anybody's familiar with that. PrimeNG, anybody? So when I first got into Angular, you're a React guy, right? When I first got into Angular, I was like, okay, what package of controls should I use? And PrimeNG is great. So they have a lot of components that are built in, dialogues and grids and calendars and all that kind of stuff. So it's a complete toolkit. And you don't have to worry about, does this thing work together with this other thing? They all work together with each other. So that's what I use for this demo here. So the other thing I would definitely recommend is if you're doing Angular, to use the Angular CLI. When I first started with it, we were doing stuff without that. And it was a very tedious cycle because you had to compile your TypeScript and do all this kind of stuff. With the CLI piece, it'll auto-detect your changes. So if I go in here and make a change to an HTML file, a TypeScript file, whatever, it'll auto-detect that. It'll cause Chrome to reload it, and I'm back in business. So it's a really great piece for that. So within here, this is my search page. And my search page basically is going to put together, well, let me just go back to it here. So this is my search page, right? Very exciting. It's got a grid, it's got paging, it's got all that kind of great stuff. And because it's all, in this case, in one page, the results from the search are available for the dialog that pops up. And so in Angular, I'm able to do that pretty easily. So right here, I define a dialog for my search parameters. And so with the search parameters, I'm going to ask you for, here's the agency. I'm going to bind that to the agency options, which I set up front when I went through the JWT and figured out which agencies you actually have access to. I'm going to ask you for the loan types and so forth. And then down here, when you click on the detail, then this dialog becomes visible, which is bound to the selected loan and pulls out that data and formats it. Okay, so it's really easy because it's JSON. It's all JSON based. It's very easy then to pull into your client-side tools and display stuff. So let me show you just one other little quick thing here. So if I go to Auth0 again, you can use this piece where you can set up different permissions within Auth0. and change those on the fly. So I've got this user. This is me, the Brian Ritchie user. So I'm going to go into my Brian Ritchie user. And right now, I'm in the super user role, right? And we saw that I had all the tokens. I could see everything. So I'm going to go in and delete this. And I'm going to add a new role. And I'm going to give myself the HUD role. Okay. And the HUD role, if you go into it, it has permissions to the HUD index. Okay. And so that's how that permission piece gets into my JWT. So I've saved all that. I'm good to go. So I'm going to go back to Mega Mortgage. Okay, I'm going to log out. I'm going to log back into Mega Mortgage. I get a new JWT, and if all goes well, okay, I only have HUD in there now. Okay. Now, if you remember, we said that on the service side, that's where we're actually enforcing this. Okay. So the UI side does some enforcement as well, because now I only see HUD in my dropdown. But obviously, this is JavaScript, so I could go in and hack this and change it all I want. So you don't really want to enforce your security on the client side. Okay, that would be bad. All right. So you can use some of the security to make the UI look better and make it update dynamically, but don't use it to enforce the security. So don't just assume because the user can only collect that box, right, that that's the only way that they can call your API, right? Because your API now is, if this is a public application, it's public on the internet, right? And so anybody can send any kind of JSON they want to it. So in this particular case, I'm still, if you look, let me show you the code here. So in my search service, I'm passing in what index I want, okay? But the index is what I'm calling a virtual index. So I'm saying, hey, I want to search loans. I'm not saying I'm a HUD person. I'm not saying I'm anything like that. And if you look back here at my search code, when I call that, all right, I'm just saying I want loans, okay? And my API now is the one that's actually going to enforce what loans I get back, okay? So I would say that would be another thing I would definitely recommend is don't try to put the index selection in the client side. You want to put that down in the service as well, because that's going to allow you to evolve potentially how those indexes are actually structured, right? Because you might start out and you say, okay, well, I want my indexes to be based on these agencies, right? But then you might say, well, maybe they need to be agency and date, right? Because they're getting so large, I want to now partition out by date. And, you know, I only want people to see certain date ranges. And so, you know, you can see the years, you know, the current year, and then if you're this other privilege, then you can see what's in history. And so it's a good idea to not try to put any kind of index naming inside the client, but let the service deal with that. Again, so you're loosely coupled with your index naming. And again, if you move away from Elasticsearch to some other tool, you don't want to be dependent on that in your client-side app. Any questions so far? Yes?
Can you talk about clustering and backups that the experience may have had based on the application that you got recently?
Yeah. So from a clustering perspective, part of the configuration when you set up Elasticsearch is you define the nodes in your cluster, okay? And it will automatically replicate between those for you. You know, you can also tell it, you know, how many you want up at a given time. So you can say, okay, I need to have this many available for my cluster to be available, okay? And so, you know, part of setting up that cluster is figuring out, well, how many nodes do I need? And then you could have nodes at multiple sites where they're replicating data to each other, or you could have, you know, two different sites. So you could have like a hot site and a cold site. And then there's tools where you can ship the data from one cluster to another. And so that's basically, if you were doing like a hot site, cold site type of thing, you would basically have an extract type of tool that runs, that ships those changes from one cluster to the other.
And do you still need the need for backups if you really have those nodes trying to automatically sync?
Well, it depends. So you can either do backups of the individual files, so kind of a file system type backup. So if you're trying to just like bring back a node that failed, you could be backing up, the entire thing. It really depends on how big your cluster ends up getting. There's a lot of clusters that are so large that the backup of the backup would be, too big. And so if you just have enough replicas up and running, then you're fine. And a lot of times this data is not your system of record data. So you might have a system of record that's your old TP database, and you're replicating to this for search. And so if you do need to restore a given record, you can just run it back through the ETL process and get it back out there.
I actually did have a question along the same line of disaster recovery. Like you said, you're keeping your transactional data on your other database, but when you have nodes go down or clusters go down, how do you rebuild from scratch? You said, or not rebuild, sorry. You said you should have like an inactive mirror or something that can feed back into the cluster, rebuild another cluster that's failed, or how does that work?
Yeah, there's different ways to do it. For us, we have a primary site and we have a backup site. Okay, and the backup site we're replicating data to, but nobody's accessing it, so it's like a cold site. And so if our primary site fails, then we can just switch over to the cold site. So that's kind of one way to do it. And then on the primary site, we have multiple Elasticsearch nodes. So if any one of those goes down, we're still up and running. So if we had an entire site failure, that's when we would go to the other site. If you're in a more of a multi-site type scenario where you've got multiple live sites, so if you have, let's say, a West Coast and an East Coast site, and they're both active, then you would just want to replicate, you'd want to have Elasticsearch on each side and be replicating across. And so you'd have kind of like one big cluster and then allow those to replicate to each other. Any other questions?
Is your API to Elasticsearch tool, is that open source?
That is an awesome question. It is going to be. So that's our intention, is to open source that. We've been kind of working through at the company to figure out how we're going to start open sourcing some of our stuff. And I've been trying to get this ready for this talk and open source it, and it hasn't quite lined up together. So it definitely will be open source soon. And so our intention is, like, we have some custom bits, if you will, within our stuff to the way we do security and stuff like that. And we don't want to obviously put that into the code that we're open sourcing. But we do want to make it extensible so that if you've got a way that you do that thing, right, you can bring that to the table, plug that in, and start using the tool. So that's where we're trying to add some extensibility points so that you can say, okay, this is how I do security. I still want to use your search API, but I need a place to plug in the way I do security. And so we're trying to get some of those things ironed out so that we can put it out there. Yes?
For Elasticsearch, is it supposed to be supplemental to your source of truth, or is it going to be your data persistent? Is it going to replace Postgre or SQL Server, or does it run alongside of that? And if it does, like, how do you keep it in parity with each other if data changes from the source of truth?
All right. So for us, because we're doing, I hate to always say it depends, but in our particular use case, our data becomes static at some point. So you can kind of think of these loan records, right? Once the loan has been finalized and the person that actually has the loan, right, all that data becomes static. Nobody can update it. And the same thing with healthcare adjudication, right? Once your claim has been adjudicated, you can't update it. You can come back and reverse it, and you can say, okay, I'm going to reverse this one. I'm going to send in a totally new one to replace it, but you can't update it. So for us, that pipeline on how the data came into our system, we would kind of incrementally update it as it went through. So that as somebody's watching the data, they can see, okay, it went through EDI validation, okay, now it's in this queue and it's moving along. But at some point, that data becomes static, and we don't have to worry about it changing. And so in that particular case, it's pretty straightforward to keep that data in sync. Things like reversals is an example of, okay, if this thing gets reversed, now I need to go back and update the status of it. But for the most part, it's static. And so you have to look at how your data is changing. If you have something that's highly updated, you're just gonna have to look at, okay, how can I encapsulate the data access and the data updates so that I'm updating both things at the same time, okay? And if you're doing it from a replication standpoint, if you're just saying, okay, I'm just gonna wait till everything gets into SQL and then I'm gonna replicate it, okay, well, that's a pretty easy way to keep things synchronized. It's also probably a little bit slower and a little bit more overhead, but it's a straightforward synchronization process. So if you can then move upstream from that and say, okay, every point that this data might change, I'm gonna either have 2 queues that receive that message or something like that to keep it in sync. There are scenarios where you could use Elasticsearch as the primary system. Like we have some event data that we put in there that says, okay, as this claim was going through our system, what are the different events that occur to it? And that stuff we just put into Elasticsearch. So it kind of is a mixed bag of how you want to do that. All right, I think we're at the end of our time, but if anybody else has any other questions, go for it.
I have so many. I can wait.
All right, well, come on up afterwards. Thanks, everybody.